Good morning. What's up? All good? Great. So today we are going to solve the first question of weekly contest 392. So let's see what is this question. You are given an array of integers, nums. Return the length of the longest subarray of nums, which is either strictly increasing or strictly decreasing. Okay, so you are given with an integer array nums, and we need to return the length of the longest subarray, right? Which is either strictly increasing or strictly decreasing. Okay, so let's see it with an example. So here you are given with this sub array. So you need to return the length of the longest subarray, which is either strictly increasing or strictly decreasing. Okay. Oh, so let's say from a single index, an array can be strictly increasing or can be strictly decreasing, right? Only one option will be possible. Okay. So we can check from every index that whether it contributes to an strictly increasing subarray or a strictly decreasing subarray. Okay, so let's say whenever let's say we are at this index. Okay. Now we keep checking on for further indexes that it is making whether it is making an strictly increasing subarray or strictly decreasing subarray. Okay, so let's see. Initially our length is 1 because our subarray has only this element, right? Okay. Now we are at this. Yeah, this is greater than this. So this element will contribute to a strictly increasing subarray. So now our length becomes 2. Now we are at here. Now 3 is less than 4. So our length of this strictly increasing subarray will be 2 only. Right? Okay. So our maximum length till now is 2, right? Now we are at this index. Now we need to check for further indexes like whether it is making a strictly increasing subvalue or strictly decreasing subvalue. So now let's check on for the next element. Again, we will initialize length with 1 as now our subvalue contains only this element, right? So now check for the next element. 3 is less than 4. Okay. So this will contribute to a strictly decreasing subvalue. Now our length will be increased by 1, it will become 2. Now we will need to check for another element that is this 3. But 3 is equals to 3. And what does strictly means? That it shouldn't be equal. It should be greater than or less than. But it can't be equal. So yeah, here our length of this array will be 2 only. So our maximum length will remain 2 only now as well. Now we are at this 3, right? So now check for further indexes that whether it is making strictly increasing or strictly decreasing. It is making nothing because 3 is equals to 3. So its length will be length of subarray will be 1 only. And in maximum length, we will be storing maximum of 2 comma 1, which is 2. Okay, now we are at this 3. Now we need to check whether 2 is less than 3 or greater than 3. Yeah, it is less than 3. So our length will increase by 1 and that it will become 2. Okay, now there are no further elements after this. So our maximum length will be maximum of 2 comma this 2. So it will remain 2 only. Now we are at this index. Again, we will initialize length by 1. Now there are no further indexes, so length of subarray will be 1 only. And here we got our maximum length as 2. Right? So let's see what's the answer for this example. Yeah, it was 2. As you can see, 3 comma 2 can be an answer, 4 comma 3 could be an answer, 1 comma 4 could be an answer. Like we need to find the subarray that is making it strictly increasing or strictly decreasing, right? And as I have told, from a single element can make either a strictly decreasing subarray or a strictly increasing subarray, right? So what we need to do is we just need to start iterating this complete array, right? And then check for each element that whether it is making a strictly increasing subarray or a strictly decreasing subarray. And simultaneously we will be calculating our length as well. And whenever our flow broken, like here it is making an strictly increasing subarray, right? But now we have encountered an element which is less than 4. So our length has become 2, and then we cannot consider 3 in our subarray. And at that point, we will come out of this loop and then update our maximum length. That's all. Okay, so let's try code this so that you will get better idea. So first of all, I will be storing the size of the nums and then initializing the result variable as all maximum length as 0 and length as also 0. Now, we will start iterating in our L, right? For each element. Now we need to check whether it is making a strictly increasing subarray or strictly decreasing subarray, right? Okay. So now we first initialize length to 1 because it always contains one element. Now we will run another loop from j equals to I, j is less than n, and j plus plus. Now we will check for first for strictly increasing subarray. Let's see. Okay. So if nums of j is greater than nums of j minus 1. So we will be checking for the second element because we have already initialized length equals to 1. It means we have considered nums I element and then we are checking for further elements for strictly increasing. So nums of j is greater than nums of j minus 1. If it is so, then we will simply increment our length. Otherwise, we will just come out of this loop. Okay, and we will update our maximum length to max of maximum length comma length. Simple. Now this is the case of strictly increasing. Now what we will doing for the case of strictly decreasing? Simply copy paste this code and then just update this sign to less than, and then we simply here also we will be calculating the length and then updating our max length. Simple. And then at the end we will be returning our max length. Okay, just try run this. Yeah, just try running for all the test cases. Um, it's taking too much time. 213 and 213. Yeah, let's try submitting it. Yeah, it's working fine. Right. So now let's talk about its time and space complexity. So you can see that we are running this loop for n times. So this will be go of n, and then another loop for n times as well. So it will be n cross n, or we can say that n is square. And what will be space complexity? It will be go of 1 as we are not using any extra space. So yeah, this was a very easy question, and this n cross n time complexity will work because as you can see here that nums dot length is 50 only. So it's 50 into 50, that will be 2500. So it is less than 10 to the power 9, obviously. I don't need to tell that. So that this n square time complexity will work because of these constraints. So yeah, this was a very easy question as it is the first question of the contest. I hope you get it. If you still have any doubts, you can post in the comment section. I will try to answer them. Till then, bye bye guys. See you in the next video.